An, an important topic that is connected to code blocks is the idea of truth and falsehood in Python. And so we'll be asking for the conditional execution, the if statements, and while statements, we're gonna be asking whether something is true or false, and if it is true, then we're going to execute a block of code. So Python provides a Boolean type that represents true, which is a capitalized true, and false, which is a capitalized false. So the objects that evaluate as false in Python are false, none, zero, and empty collections such as empty strings, empty tuples, empty lists, empty dictionaries, and empty sets. And everything else, with certain caveats, evaluates as true. And Python comes with the function bool, which converts any expression that can be to a Boolean value of true or false. So let's look at how these work. So does false evaluate as true or false? Not surprisingly, it evaluates as false. So here I'm asking, is an empty list true or false? Well, if we come up here, we see that an empty collection should evaluate as false. And indeed, we get false. Here I've got a list with a value of 1. It evaluates as true. Here I have a list with a value, an element that's 0. So is this false because 0 evaluates as false? Or is it true because it's a non-empty list? Well, this is true because it's not the values that are in the list that are being evaluated, but the presence or absence of any values in the list that are being evaluated. Okay, here I have the expression 2 minus 2. So we've got a 2, which is non-zero, should evaluate as true. But what's happening is the expression 2 minus 2 is evaluated first. It evaluates to 0, and 0 evaluates as false. Python has a variety of comparisons we can make. We can test whether two variables, x and y, are equal with a double equal sign, not a single equal, again, which is an assignment. We can ask whether x is less than y, whether x is greater than y, whether x is less than or equal to y, whether x is greater than or equal to y, whether x is not equal to y, whether x is y. That means that they're the same object, share the same memory location in the computer. We can ask if x is not y. If y is a collection, we can ask if x is in that collection. And similarly, we can ask if x is not in y, if y is a collection. Python also comes with Boolean operators that allows us to combine these different comparisons and questions that we might ask. So there's ands, ors, and nots. So and means, and these Boolean operators are going to again evaluate as true or false. So x and y is true if both x and y are true. If x is true and y is false, then x and y is false. X or y evaluates as true if either x or y are true. They don't both have to be true. Not x is true if x evaluates as false. Okay. Now, and or operate in what's called a short circuit manner. So with the and, both the left and the right of the Boolean operator have to be true. So if the left evaluates as false, Python never bothers to ask anything about the right because it knows no matter what y is, since x is false, x and y must be false. Similarly with or, since only x or y need to be true, if x evaluates as true, then it doesn't bother to ask anything about y because it doesn't need to ask that in order for the question for the expression to evaluate as true. So here are just some simple examples. I'm defining some variables, x, y, and z. if we put these in of how they will evaluate, we'll get a true, false, true from the variables, true, false, true. And then we can do different combinations of this. So if we say x and then we have in parentheses, so then this expression is y or z, then this evaluates as true because while y is false, z is true, so this or evaluates as true, x is true, and so we get a true for the overall expression. What if we drop our parentheses here? We still get the same thing, and this is an illustration of order of precedence of the operations. Now, NumPy arrays are a little bit different, and we have I have a link here to the web page for the documentation showing the different logical questions we can ask about NumPy arrays. And here I've defined a NumPy array of two of them, 1, 2, 3, 4, and 0, 1, 0, 1. Now, first off, for just illustration, you see here, if I take a list, 1, 2, 3, 4, and I ask if it's true, it evaluates as true because it is a non-empty collection. But if I were to do that as an array, I get this value error that the truth of any array with more than one element is ambiguous. So the arrays are being treated fundamentally different than the native collections in Python. So there are various questions we can ask about these arrays. So if we look here at our list, at the very top we have all or any. So test whether all array elements evaluate to true, test whether any given any elements in the array evaluate as true. And because arrays can be multidimensional, we can limit it to particular axes if we want. So let's ask whether A has any that are true. And yes, all of these in A evaluate as true. So if we do all, we get true there. If we ask are all the elements in B true, we get a false because we have zeros and ones. But if we ask if any are true, we're going to get a true. We can also do call functions that compare element by element between arrays. So I can do a logical AND of A and B, and this will return an array where we look at the first one, 1 and 0 is false, 2 and 1 is true, 3 and 0 is false, and 4 and 1 is true. And we could do an OR. In this case, they all turn out as true, but if we put like a 0 there, and we do we get a false now on our OR because 0 or 0 is false, whereas all the others, 3 or 0, evaluates as true. All the others evaluate as true.